Good day and welcome to One-on-One Maths Private Tutors. We continue with O-Level and IGCSE Chemistry for Pure Chemistry and Combined Science. The topic is Identification of Ions. This section is testing for anions. Anions are negatively charged ions. These are non-metal based ions. We are going to look at the test for halide ions. Halide ions are group 7 ions, such as chloride ions, Cl-, iodide ions, I-, and bromide ions, Br-. Aqueous silver nitrate is used to test for halides. Chlorides give a white precipitate, bromides give a cream precipitate, and iodides give a yellow precipitate. Now we look at an experiment to test solutions if they contain chloride, bromide, or iodide ions. We use two reagents: nitric acid to get rid of any carbonates, and silver nitrate. So we add nitric acid first to our samples to make sure there are no carbonates in any of them. Now we take silver nitrate we put a few drops in each of the solutions. So this is the color difference. Chloride ions produce a white precipitate of silver chloride, and a cream precipitate of silver bromide is produced, and a yellow precipitate is produced of silver iodide. There is a slight difference between silver bromide and silver iodide. Silver iodide is more yellow, silver bromide is more cream. The color difference is very close. Now, carbonates produce carbon dioxide on addition of an acid. So we have a solution containing carbonate. So carbonate reacts with any acid to produce carbon dioxide. So we are going to put an acid into the carbonate containing solution, then tap off the gas produced into lime water. We should expect the lime water to turn milky. We will add dilute acid there and capture the gas produced and transfer it to our lime water. So this is the gas produced, and we can see the lime water turns milky. Sulfates produce a white precipitate on addition of acidified barium chloride. Let's look at an experiment where we have a solution containing sulfate ions and we add acidified barium chloride. So here we use barium nitrate because barium and sulfate ions react to give a white precipitate. But barium nitrate also gives a white precipitate if you add to carbonate ions. So to distinguish between carbonate and sulfate and to eliminate the carbonate in both solutions, we first add nitric acid. Because carbonate reacts with acid to give carbon dioxide. So by putting acid in both test tubes, we are eliminating carbonate. After that, we add barium nitrate. Now we know the white precipitate that forms is only due to the sulfate ions. So we see For sulfate ions, barium produces a white precipitate. But for this solution that no longer contains carbonates, there is no precipitate. Nitrates release ammonia when heated with sodium hydroxide and aluminium foil. Let's look at an experiment to test for nitrates. So we'll use sodium hydroxide and aluminium foil. When we heat up nitrate ions in the presence of sodium hydroxide and aluminium foil, we will have ammonia. Then we can test for ammonia. So put some sodium hydroxide, then we drop in the aluminium foil. Then we heat gently. Then we use damp red litmus paper to test for ammonia gas. So we will heat this mixture until bubbles are produced. So the bubbles are now forming. Then we put our damp red litmus paper on the mouth of the test tube. Then we observe the change in the color. So the red litmus has turned blue due to ammonia gas. Now we can say the solution contains nitrate ions. Sulfites release sulfur dioxide when heated with hydrochloric acid. Now we're going to see an experiment where we use sulfites and have sulfur dioxide. So we are testing for sulfite ions. So here we have sodium sulfite. We add hydrochloric acid to the sodium sulfite. We may heat it up to quicken the reaction. Then we take a piece of paper. Again, we add hydrochloric acid to that piece of paper. Then we dip it in potassium manganate. Now on the piece of paper, we have acidified potassium manganate. Now this reaction of sodium sulfite and hydrochloric acid should produce sulfur dioxide. So to test for sulfite, we test for the production of sulfur dioxide. So we take a piece of paper with acidified potassium manganate to the mouth of the test tube. The gas that is coming out from the test tube is sulfur dioxide. So we will observe the paper decolorizing, which means acidified potassium manganate turns from purple to colorless. So we see the paper turns from purple to white, which means that the acidified potassium manganate has been decolorized. Now let's look at this question. A sample of compound R is heated with aluminium foil and concentrated sodium hydroxide. A gas is produced which turns damp red litmus paper blue. Identify the gas and state the name and give the formula of the negative ion present. So from our theory, nitrates release ammonia when heated with sodium hydroxide and aluminium foil. So the gas is ammonia. So we have identified the gas and state the name and give the formula for the negative ion present. The negative ion present is nitrates, which is NO3 minus is the negative ion present. So the gas is ammonia. The formula for the negative ion is NO3 minus. So for a recap, aqueous silver nitrate is used to test for halides. Nitrates release ammonia when heated with sodium hydroxide and aluminium foil. Sulfates give a white precipitate with barium chloride. Sulfites release sulfur dioxide when heated with an acid. So we will test for the sulfur dioxide using acidified potassium manganate, and it will be decolorized to turn from purple to colorless. Okay, now that we have done everything concerned with identification of ions, making salts by precipitation, identification of ions, let's look at past exam questions. Let's look at this question from O-level pure chemistry question paper 4, alternative to practical paper for November 2024. A student investigates solid Y and solution Z. Solid Y is a white powder. The tests the student does on Y are shown in the table below. Some of the observations for these tests are also shown. Test on solid Y. If we add excess dilute acid to Y in a boiling tube, a colorless solution is formed. The gas produced is tested using lime water. So the gas, after adding dilute acid to solid Y and boiling it, is tested using lime water, and lime water becomes milky. So straight away, we see that this forms a carbon dioxide, which means the powder had carbonate ions. Add dilute nitric acid to some of the solution from test 1. So from test 1, the colorless solution formed, we add dilute nitric acid and then add aqueous barium nitrate. We see that a white precipitate forms. If we add aqueous sodium hydroxide drop by drop to some of the solution from test 1 until a change is seen, we see that a white precipitate is formed. If we add excess aqueous sodium hydroxide, the white precipitate becomes soluble, giving a colorless solution. If we add aqueous ammonia drop by drop to some of the solution from test 1, a white precipitate forms. If we then add aqueous excess ammonia, the precipitate is soluble, which means it dissolves, giving a colorless solution. Describe how the gas is passed through lime water in test 1. You may draw a label diagram to help answer the question. So we use a delivery tube. So if we have our reactants in a test tube, we will use a cork connected to a delivery tube. So this is how we use a delivery tube. Our solid Y and acid are in there. Any gas that is produced go through there into the lime water, and we can have our observation. Describe 2 other observations the student makes in test 1. So colorless solution formed, lime water becomes milky. What other observation is made when excess dilute acid is added to Y? The solid dissolves completely, bubbles or effervescence seen. Identify the gas produced in test 1. The gas is carbon dioxide. Because carbon dioxide turns lime water milky. Y contains 1 anion. An anion is a negatively charged ion. So from the observations of test 1, we can say it is a carbonate, or CO3 2-. Use the observations from test 2 to identify the dilute acid used in test 1. Dilute nitric acid is added to some of the solutions from test 1, then add barium nitrate. A white precipitate is observed. Since all nitrate salts are soluble, we'll see which ion will form a precipitate with barium. So we go to our notes in qualitative analysis, which is the last 2 pages of our exam paper, and go to the anion section and search which one will give a white precipitate with barium nitrate. So this is our negative ion for the acid, since it gives a white precipitate with barium or barium nitrate. So we must learn to use these tables. So we have the sulfate ion. So the acid that we are looking for is sulfuric acid, or H2SO4. Identify the cation in Y using the observations from test 3 and 4. Add sodium hydroxide drop by drop some of the solution from test 1 until a change is seen. We have a white precipitate when we add sodium hydroxide, and when we add excess sodium hydroxide, it becomes soluble. So we go back to our tables and now use the aqueous cations. And we'll see that for zinc 2 plus, a white precipitate forms when we add aqueous sodium hydroxide, but when we add excess, it becomes soluble, giving a colorless solution. So this description is similar to this description at 3. Add aqueous sodium hydroxide drop by drop to some of the solution, white precipitate. Then add excess aqueous sodium hydroxide, it becomes soluble, giving a colorless solution. So that is zinc 2 plus. So here we have, but this is also similar to aluminium. You can see a white precipitate when we add sodium hydroxide, and when we add excess, it will be soluble, giving a colorless solution. So our question is saying from test 3 and 4. So far we have zinc 2 plus and aluminium 3 plus. Now we go to 4. Add aqueous ammonia, a white precipitate, then add excess aqueous ammonia, it becomes soluble. So we'll contrast zinc and aluminium, and we'll see that for aluminium, it will be white precipitate when you do drop by drop of aqueous ammonia, but insoluble in excess. But for zinc, white precipitate when you do drop by drop, but soluble in excess. So we are looking for this soluble in excess, which is zinc. So that's how we eliminate aluminium, because in excess ammonia, aluminium remains a solid precipitate. It doesn't become soluble, but zinc ions do. Solution Z is colorless. The student thinks that Z contains copper 2 ions. State why the student is not correct. So from theory, we know that copper 2 produce colored solutions. So if it's colorless, then it is not a copper 2 salt or compound. So we can say Q2 plus ions give colored salts or compounds. Solution Z contains potassium or K plus ions. Describe how to do a flame test on solution Z to confirm the identity of this cation. So this information on flame tests, we also find it on our notes for use in qualitative analysis. At the back of our question paper, we have flame test for metal ions, flame color. So we should refer to this table in the exam. It is always given for paper 3 in combined science and paper 4 alternative to practical. First, we dip a splint into solution Z Then we put the splint into a blue Bunsen flame. Then we note the color of the flame. If Z contains potassium ions, the flame turns purple or lilac. Solution Z contains ions of group 7 elements. Our group 7 ions are chloride, bromide, and iodide. So the test is to add dilute nitric acid, then add aqueous silver nitrate in all instances. So if a white precipitate is observed, then we know it is the chloride ion. If a cream precipitate is observed, then we know it's the bromide ion. And if a yellow precipitate is observed, then we know it's the iodide ion. So we can say add dilute nitric acid, then add aqueous silver nitrate. If a white precipitate is observed, then there are chloride ions. If a cream precipitate is observed, there are bromide ions. If a yellow precipitate is observed, there are iodide ions. Now we go to O-Level Combined Science 5129, paper 31 for June 2024. Magnesium sulfate is a salt. A student prepares pure crystals of magnesium sulfate. The student measures 25 cubic centimeters of dilute sulfuric acid into a flask. He then adds insoluble solid magnesium carbonate to the mixture until in excess. Separates the excess magnesium carbonate from the liquid. Heats the separated liquid. Name a piece of apparatus suitable for measuring 25 cubic centimeters of sulfuric acid. You may use a measuring cylinder, a pipette, or a pipette. State 2 observations that show that the magnesium carbonate has been added in excess. So we have to understand the reaction that takes place. So we have magnesium carbonate and the sulfuric acid. Magnesium carbonate is a solid. Sulfuric acid is in solution. This will give us magnesium sulfate in solution plus water, a liquid, plus carbon dioxide gas. Now, if the magnesium carbonate is added in excess, some of it will remain as a solid. So, if a solid remains after the reaction has stopped, then we know we have added magnesium carbonate in excess. So we can say solid magnesium carbonate remains undissolved. And when the reaction stops, the bubbles of carbon dioxide stop forming. So we can say bubbles stop forming. So these are the two ways we can see that magnesium carbonate has been added in excess. Solid remains and bubbles stop forming. Name the process that the student uses to separate excess magnesium carbonate from the mixture. Filtration. So in this process of filtration, we use a funnel and then a filter paper inside there, then pour in our contents there. What will happen is the solid magnesium carbonate will remain there. Then we collect the magnesium sulfate solution. The magnesium carbonate is the residue, while the magnesium sulfate solution is the filtrate. So that's how we do the process of filtration. Explain how the student knows that the mixture has been heated for long enough. Okay, let's look where heating. Heats the separated liquid. So after filtration. This liquid of magnesium sulfate solution is heated. So we want to make crystals. So we start seeing solid or crystals start to form. We see solid or crystals start to form. Then we know this solution is now saturated. So in order to make crystals, is required pure crystals is what we want to form of magnesium sulfate. So after heating the separated liquid here, we see solid or crystal starting to form. Then we know this solution is now saturated. Describe what the student needs to do after heating the separated mixture in order to obtain pure crystals. The student has to remove the mixture from the flame and allow it to cool. Then dry the crystals with a filter paper. Another student prepares lead sulfate. Lead sulfate is insoluble in water. The student has insoluble lead carbonate, insoluble barium oxide, lead metal, aqueous lead nitrate, dilute sulfuric acid, aqueous sodium sulfate, dilute sulfuric acid, aqueous sodium sulfate, insoluble barium sulfate. Select 2 chemicals from the list which are suitable for the student to use to make lead sulfate. So since lead sulfate is insoluble in water, we would want to do a precipitation reaction of one soluble substance containing lead. So aqueous lead nitrate here is one ingredient, and we want another soluble substance which contains a sulfate. So we can have dilute sulfuric acid or aqueous sodium sulfate. So aqueous lead nitrate and sulfuric acid or aqueous sodium sulfate. So you have a choice between dilute sulfuric acid or sodium sulfate. State 2 reasons why the method used for making magnesium sulfate is not suitable for making lead sulfate. So we see in the previous question, we're making magnesium sulfate. So the first reason is magnesium sulfate is soluble. Lead sulfate is insoluble, and there is no way to separate the pure product. Name the method used for making lead sulfate. The method is precipitation. Okay, so that is how you answer exam questions. We have covered paper 3 for combined science and alternative to practical for pure chemistry, and we have used the notes for use in qualitative analysis at the back of our examination paper. Thank you.